So let's batter through a little bit of functions and sets. Oh, next question's in there. This is quite a nice little section, I think. It's kind of quite easy marks in the bag. It's just more about how you lay things out. I think I don't think there's too much in this. So hopefully one or two videos we should get this knocked out. So function h is defined by this. This just means where x is a real number. So don't worry too much about this. And then find the inverse. Inverse is working back the way. This is what are we doing to x here? We're dividing it by 3, we're adding 4. So let's go back the way. The first thing you want to do is write it out as y is equal to 4 plus a third x. What we're doing is rearranging to make x the subject. So you're doing BODMAS in reverse. You'll say that y, take away 4, is equal to 1/3 x. Now that's the same, don't forget, as x over 3. Then you're saying that 3 y take away 4 is equal to x. And our final step is then to say, okay, well that means that, oops, say h there. That means that h to the negative 1x is equal to 3, and we change y to x. Sorted. So all you're doing is rearranging to make x the subject. If it said that, you would say, well, that's pretty easy, and you've just got to watch out for some notation. So yeah, not too bad. That's how much was that worth? That was 3 marks for that question. 3 marks. Pretty nice. Let's do the same again, but this time a slightly trickier function. So I've got, same again, y is equal to x cubed plus 7. That's all this. This is just different notation really for y. This is just saying that a function, with respect to x, we can then rewrite that as y. Rearrange BODMAS in reverse. Y take away 7 is equal to x cubed. So that means that the cube root of y take away 7 is equal to x. So therefore, the inverse of h is the cube root of x take away 7. Just doing the exact opposite. If you knew this output, how would you work out the input? It's kind of like your number machines from second year. This is saying that I've got x and I'm cubing it. So you're cubing your number and then you're adding on 7. Add on 7. Oops, and that gives me my final answer. And you're just saying, well, I want to work back the way. So you're taking away 7. You're cube rooting. What was the number that I put in? X. Exactly the same as that. Just working by the way, but we've got some fancier. So yep, a few good marks in the bag. The only thing that can make it a wee bit trickier is if they're asking you to put functions into other functions. So here the first one, evaluate fg of 0. So all that means is work out what g of 0 is and put that into f. And so the first thing I do is say, okay, well g of 0 is the same as 2 cos of 0, because that's g of x. If I wanted to write down g of z, I would say, well, that's 2 cos z. If I want to do g of 4, that's going to be 2 cos 4. You're just substituting in the number here for the variable for there. So I've got g of 0. Now cos of 0, we're going to have to say, right, let's think about that. Here's my cos graph. So cos of 0 is here. So that's going to be 1, isn't it? So g of 0 is equal to 2 times 1 is equal to 2. That's your first bit. And then I want to substitute that in. Just rub this out, give me some more space. Although don't rub it in the exam, leave everything. And I want to put that in. So I want to do f of 2. That's going to be 5, 2. That'll give me 10. Looks like 16 that I've drawn there, but that is in fact a10. And the very last one, put f into g. Okay, that's all that means. I'm putting f into g. So where's my g function? So I'll say g f of x. Let's just write my g function. So that's 2 cos. I don't write out x. I'm going to write out f of x. So f of x is 5x. I'll just say 2 cos 5x. Sorted. So you're just putting in that function into the other function. Next one. And the very last one, again, this sounds complicated, but it really isn't. So g to the negative 1x, let's do that first of all. So y is equal to 6 take away 2x. See, it's very similar if you find these questions and you do them. So take away, so this is meant to look a wee bit trickier. Let's just, if you wanted, you can think on it like that. That means it's y take away 6 is negative 2x. That means it's y over 6 divided by negative 2. That is all equal to x. So that means that g to the negative 1x is equal to x take away 6 divided by negative 2. So yeah, when you start doing these, you see the patterns are just, it's very, very similar, isn't it? The only thing, I'll show you this. I'm not sure. I'm going to have to check the marking scheme actually. You might argue divide by negative looks a bit messy. So if you do that, the signs on the top could change to divide by 2. That's the same thing. You know, if you divide through by the negative, argue that. We'll check the marking scheme. I think that might still be okay. But just if you thought you could do it in steps, you could divide by negative 1, then divide by 2, just to show you that. And the very last bit, this is the real thing I want to show you. This looks very complicated, doesn't it? So you get a function g and you're putting the inverse into it. So what does that actually mean? Well, if I wanted to write it out, I'd say, okay, well, g of x, g to the negative 1x. So I've got my function of g, so it's 6 take away 2. But instead of x, I'm putting in the inverse. So I'm going to put in negative 2 times. I'll write that second one out. Negative x plus 6 over 2. So it looks quite messy, you know. Let's see if we can work some of that out. So negative 2 and 2, that's just going to give you negative 1, isn't it? So that would become negative 1, negative x plus 6. That gives me 6 plus x take away 6. Oh, so I'm just left with x. Did I expect that? Yeah, absolutely. If you were to put the inverse into the original or vice versa, you always end up with what you got in the first place. So you can work it out if you want, but that's just a one mark question where you should be able to say, I recognize this, X, and you don't have to do the working. But if you want, you can do the working to satisfy yourself, or indeed you could always do that to double check you've done any of these questions correctly as well. But yeah, if you were to do g to the negative 1, g of x, you would end up with x, just the same way that g to the negative 1 of x gives you x. You're just working back to where you started off with. Okay, so that's the first sets of questions. I've really took a bit longer than I thought actually. I'll just zoom out so you can see them. All you need to remember is you're rearranging, go left, yeah, you're rearranging to find that x, and then you use the terminology, the inverse, and you change the y to x. That's all we've done. Things like this just means do g of 0 first. And you see how they made it a bit tricky there. They were tying in your trig knowledge. And the little curveball they can throw you is this, but that always equals x. You see, it's a 1 mark question, so you know there's not a lot of work in it. But if you wanted to check it, you absolutely could. So that's the first one about the inverse. The next one, we're going to look at limits and then some trickier questions. We'll get that done in a video, I think. So yeah, thanks for listening. I hope that was helpful. And these are good marks to bank in the exam. So please, have a wee look at these.